All right, well, let's go ahead and get started. My name's Jim Mansfield. I'm a senior manager with Matrix Technologies, and then the awesome responsibility of leading our manufacturing intelligence division. I would like to welcome everybody to part 3 of the 6-part Matrix Technologies webinar series. This third and fourth part that you're going to get an email on shortly after this is really focusing on what's the value. So just a quick agenda and run through. We got we'll hit the welcome, a brief introduction to Matrix Technologies, definition concepts, what is ISA 95 and the unified namespace, adding intelligence, minimum technical requirements, the design considerations there, functionalities that are built in, the security considerations, the Purdue security model, inherently secure systems, and then finally with Q&A. I'm joined today by David Schultz and John Lee. Let them do a quick introduction to themselves right after we finish the welcome piece. Dave, can you scroll down there? Thank you, sir. So a little bit about Matrix Technologies, going on 42 years old this year, and starting back in 1980. Matrix is a multidisciplined engineering, process, and automation engineering firm with a core focus for our industrial manufacturing clientele. Today, 320 employees, I think 46 active job postings, growing like a weed, probably hitting towards that 75 million, not 65 million anymore. 7 locations across the Midwest, all the way down to Atlanta and well over to Denver, Colorado, to support our clients across the United States and globally. We've done projects in 45 countries, and we're fortunate that our growth is speared by 85% of our clients are repeat work every year, which is exciting. So I won't go through all of our capabilities. There are a lot there. Obviously, today we're going to be focusing on how we integrate our industrial systems division and industrial networks and our manufacturing intelligence division to deliver digital manufacturing and the transformation thereof. From the services, if you can think about a discipline out there, chances are we likely have them internal of our organization. So again, nothing coming from a processor facility and having the capabilities to handle these projects, single source. Markets are represented. Most industrial markets we have clients in today. Again, I'm not going to go through them all. Just kind of do a quick read through the bottom of them if you get an opportunity. So at this point, let me turn it over to David and John. Let you guys kick it off and look forward to today and the next series.
All right, thank you, Jim. Well, I'll go ahead and get started. So I am David Schultz. I am a solution architect, and my role is to help manufacturers with their digital transformation journey, as well as do the systems architecture of when those solutions finally get deployed at your manufacturing site, put together all the various technologies that are going to be used for solving the particular challenges that you're experiencing. 25 years of process control and automation experience and all of the markets you see represented there. So chances are whatever you guys are making, I've probably either worked directly with you or somebody that does something similar to what you do. So that's who I am. Thanks for being here. Looking forward to the conversation. So, John?
Yeah, sure. Thanks, David. John Lee with Matrix, about 15 years now. I'm a department manager for manufacturing intelligence solutions. So I run the implementation group. So kind of the counterpart to Dave and working with the architecture teams. So my background for about 3 decades has always been in databases and programming. So architecting different systems, information systems, and a few different areas, including military applications, information systems for healthcare. And then the last 15 years with Matrix has all been around manufacturing. So excited to be here, and thanks everyone for joining.
So what we're going to spend some time talking about is just, the value of what gets known as the unified namespace. How all does it work? And what is it? How do I leverage it? Where does all this stuff fit? I don't get it. It's I've heard it, but I need a little more definition. Before we get into it, I think it's really important to understand some of the manufacturing technology and best practices that have existed in manufacturing since the mid 80s. And I'm sure people are familiar with the ISA 95 standard. And that still continues to be a very good guidebook for how it is we're going to deploy these particular solutions within our plants. There's a lot of great material that's there and best practices, and we want to continue on with those. So there's actually 8 different parts to the ISA 95 standard. And so when people refer to it, realize there's a portfolio and a lot of different capabilities and definitions that go into that. And most people are just familiar with the part 1, maybe part 2. So part 1 just gives you the definitions, and we're all going to agree on when we use a term, what does this term exactly mean, so that it creates a common language for all of us to communicate back and forth. And so that becomes the part 1 portion of it. That's mainly what it's there. Part 2 is where you get into a lot of the objects and the attributes for the control systems. So this is now starting to put some boundaries around the types of systems that you will expose yourself to within the manufacturer you'll be exposed to in a manufacturing environment. So this is where you start getting into what is SCADA, what is SCADA data, how often does SCADA data refresh itself, and then who owns SCADA, what are the boundaries for that SCADA system. Or as you get into the MES piece, that's where you're going to define, okay, what is MES? What are the functions of MES? What does the MES data look like? And provide some boundaries and how all this information gets connected together. So, what you'll see here in this graphic is what's commonly referred to as the ISA 95 structure or hierarchy that utilize and segments all of these systems out there. So starting at that level 0, that's where you'll get into all your devices. This is the hardware that's actually connecting and touching your particular process plant. Then you'll get into the control systems. So depending on what it's doing, it's a level 1, level 2, and you'll get into more of the controls from the PLC into the SCADA, the historian for. Now we're going to start capturing some of that intelligence, some of that value that's being delivered to us from those level 0 devices that are on the plant floor. Level 3, we get into the more manufacturing execution systems or the manufacturing operations management. So this is how you actually take some of the sales order that you get at, from your enterprise resource planning system, and how do we actually go from this order to cash? What does that process look like? And what are some of those systems that fit in there? And as I mentioned earlier, you have the business systems, you have your enterprise resource planning, warehouse management, product lifecycle management, those types of things. And while not specifically defined within the ISA 95 standard, you're also going to look into or get involved into some cloud. And I don't mean to say this is going to sit on top of everything, but this is fundamentally how we like to segment everything out. So this diagram is really demonstrating what that part 2 piece is. Part 4 is where we're going to get into a lot of these objects and the attributes for the manufacturing operations and management. So that's that middle layer, that blue piece, MOM, MES in there, and that thing covers things like actually, scheduling work orders, managing production work orders. What's our quality look like, in terms of, say, an SPC, or, our genealogy, the track and trace, overall equipment effectiveness, the OEE. CMMS is actually an MES function because it speaks to the maintenance. And then we also want to get involved in the energy. And what we're trying to do is both manage the process of what we're actually going to make, as well as we're going to measure that information that comes back. So the part 4 is getting into the concepts of these process segments and operations definitions and response segments, request segments, all of that information, and how that information, where you go from a process segment to getting that response piece back. ISA 95 part 4, if you're having a hard time sleeping at night, it's a great read to assist with that, but there's a lot of good meat material that exists within that. And it's important to understand how all this information is getting passed back and forth. So take a brief minute there. So John, I don't know if you have anything or thoughts that you wanted to add to this, but now would be a good time to, anything else that you might want to speak to in this particular section.
Sure. That, at that level 3, as you mentioned, the operations management, object attributes, that MES does fall in there. That's all the work order execution, scheduling, and that's also where we do a lot of measurements. So not only are we, executing production and tracking things, we're also consuming a lot of information within that level. And that's a key one, really to, advance and run operations. You can always still run the machinery, but if you can't understand what you're running and how well you're running, that's where that operations management and all the components in there start to play into that. So it's a key one, David. Like you said, that part 4 is kind of a maybe not a very interesting read, but it's a good read.
Yeah, absolutely. And this is how all that information fits together. So as I mentioned on the last webinar, how people are informed or they understand, or I like to say how they get ISA 95 is this hierarchical structure, meaning that my devices connect to my control system connects to my MES connects to my business system. That is the flow. There's no device connecting to the business system. And in some ways, yeah, that's probably not relevant. But what that's created is this point-to-point architecture where I have to move through all of those layers before I can start presenting some information in there. And what's interesting to me is ISA 95 really, it's just all about putting some boundaries and some definitions and some guides around what does this manufacturing information look like. But nowhere in there does it say that you absolutely have to connect all of these systems this way. It's a functional specification. And as Jim mentioned, we're going to talk a little bit about the Purdue security model a little bit later. That's how people have been approaching the overall security on these systems, is going through all these various layers. And ultimately, you really don't have to do that. And part of this, what's the value, is there's a better approach for doing this, and that is exactly what this unified namespace is.
Yeah, I mean, it's pretty obvious in the graphic. It looks stacked and it's very vertical, right?
Mm-hmm.
So David, as you go through this one, you'll see it's just different when you look at it.
Mm-hmm. Yeah, so utilizing another common graphic that we have, let's get into this unified namespace. And what is it? From a definitional standpoint, it is your single source of truth for all the data and events that occur within your manufacturing and your business process. It also follows the structure of your business. So when we get into this ISA 95, the part 2, we're going to continue to follow that structure. Reason being, it's because your master data model or your common data model that exists probably within your ERP, we want to leverage that same structure of the overall information, because the goal of a unified namespace is to make sure we're presenting the data, the asset information, as well as the process information and the application information in a way that makes sense. And it's important to have that overall structure there, so as you're visualizing and looking at it, you know exactly what it is you're looking at. There's not this, gosh, what is this? I mean, think of a PLC tag. Sometimes those tag names are very obscure what you're actually looking at, and that's where this information is going to start putting some context to it. So that's the idea. A unified namespace is a strategy. It's an approach. It's a design consideration. It's not a product per se. It is not this piece of intelligence or this technology. I'm going to go out and go to my local software vendor and buy myself a UNS, much like you might buy a CMMS or some kind of manufacturing execution system. It's a design approach that utilizes some underlying technology. But what it's going to leverage is that functionality that exists within ISA 95, that rather than creating this stacked layer of all of my processes in the information flow, I'm actually going to connect it through a common technology ecosystem that all of these nodes can then publish and subscribe their information. So when I have an event that occurs on the plant floor, that information is going to get presented in a way utilizing a semantic data model that other systems can consume. You no longer have this point-to-point connection. All of the functionality within your enterprise becomes a node within an ecosystem. So the design approach is, how do I connect my systems together? How do I present information to other systems that we're able to publish and subscribe where all of that makes sense? A common technology we use for this is MQTT from a brokering standpoint of a lot of your telemetry data, but you're also going to need some other capabilities in there. How do I query the information? Where do I store the information? And if I'm trying to get messages from one piece of software, if I want to create and schedule a manufacturing work order, how do I actually know that that made it down to the line? Because that doesn't exist. So unified namespace, it's a design approach, it's a design methodology, it is a strategy for how we're going to connect our systems together so that there's a common endpoint for all that information exchange, both between systems to systems as well as people to systems. So, John, any thoughts you'd like to add on that?
Yeah, so just question. So in the approach here, David, as we talk about moving away from point to point, we're also kind of talking about moving away from client server, right?
Mm-hmm.
Okay.
Yeah, absolutely.
That's where the brokering technology comes in, right?
Yeah, so specific to the broker, and this is something we'll talk a little bit about in the security aspect of it, is that rather than a server instantiating a connection to a client, we want to try to leverage the idea of a client connecting into that common technology and ecosystem. So, I don't want to get too much ahead of myself, but much like when you're at home and you want to tie into your bank account, you instantiate the connection to that central server. So, you maintain that connectivity. It's done securely. We use TLS for making that connection. Specific to a broker, it does the exact same type of thing. The other advantage to doing this is in that semantic data model. It's because I'm producing the intelligence, I know what intelligence I have. So if you think about when you do an API request, that's an application programming interface. So that's how I get information from one system to another, commonly speaking. I only get the information that I asked it. So if I say, give me this, that's all I'm going to get. There may be other intelligence there that you are not asking for that might be of value to you. The advantage of using a client instantiation is not only from a security standpoint, it also means here's all the intelligence, here's all the smart stuff that I have. I'll tell you what is here and you decide, is that something that I want to utilize? And that's one of the powerful aspects of utilizing this and getting that information flowing in there.
Yeah, I would also note, David, as you say, there's an ecosystem here, and you can see the nodes in the visual graphic, right? There are other synonymous things, right? So we talk about the unified namespace and the single source of truth. Building the data models, there are other models that you find in other solutions, maybe software stacks. They have the common information model out there, model-based design offered by vendors. I think what I see still is that's still kind of vertical though, right? So that's not really opening it up in the same way that the unified namespace does. Would you agree?
Well, sort of. Yeah, let me rephrase that. Yes, I would. And it's actually a great segue into the next thing that I would like to talk a little bit about. So, now that we understand that it's just a fundamental architecture and approach and strategy for how we're going to start exchanging information, all the smart stuff that's connected together, what does that look like? And what I really want to avoid, and it's sort of, there's still a big debate on, what I'll call the platform and the anti-platform. But from my standpoint, it's in the approach is that if we use a common technology ecosystem that all of these systems will support, and I can exchange that information easily, that's really the preferred way. Because when you start taking a look at, and I'll go back up here real fast, all the various systems that you're going to have across your enterprise, you might have an OEE solution that has a horrible genealogy or track and trace system. But because of the platform approach, you're forced to use a solution that may not be in the best interest of your business. So if you're supporting a common technology ecosystem, that means you can choose the one that works the best for your particular application because you've built in this ecosystem that everything can connect to. So one of the pieces that we talk about is the minimum technical requirements. So within these Industry 4.0 systems utilizing an IoT approach, we want to make sure that all of our technology it's an open architecture. And what I mean by that is it plays well together. I want to be able to exchange information across a technology. So like MQTT and a Sparkplug-B payload, so long as all of my devices support that, I can very easily exchange information. That specification is public. It is available. Many devices now support it. So I know I can make this common technology, and it's open. I don't have to pay a license to utilize the technology. It's all out there and it's very easily understood. The next one is lightweight. And this sort of comes back to this poll response and some of the other pieces that are on here, is that because I'm going to be utilizing more information and creating more data, remember, it's not just those nodes of these functions. There's going to be a lot more sensors that I'm going to connect. You need to make sure that the underlying technology and infrastructure can support all of this new information that's coming across. Excuse me for a minute. I need to get a drink of water. Yeah, apologies. That's the downside when you're talking. Is that if I'm connecting in new devices to my ecosystem, I need to be able to support that. So I need to make sure that I have a lightweight communication protocol. I can't have a big, heavy payload from all these devices that are moving across the ecosystem. The next one is the report by exception. So we talked about the client instantiation, and instead of having a server do it, the client does it. Another benefit to that is this report by exception, meaning I only publish and send and transmit information when there is something new. And if you think about, when I was a kid and we're doing the family vacations, the most common question we ask is, are we there yet? And the answer is no. And so that gets asked a lot. There's really no new information, but I continue to do a poll and then I get a response. Well, that's in a network situation, you're now consuming resources that you may not need to do. But if you're doing a report by exception, where now the parent says, all right, guys, we're 10 minutes to grandma's, get your shoes on, that's report by exception. There's new information. So there's new information that's being presented. And then finally, edge driven. So this goes back to that, whatever is producing the intelligence, you want that, it tells you everything that it knows about itself. And so you want all that communication, you want all that information, you want that to be driven by the piece of technology that's producing it. Is that making sense, John?
Yeah, that's a real good explanation. There's a lot of questions about the report by exception. I think you explained it rather well. I like your analogy.
Yeah, that's and everybody loves the family vacation because we all think, oh, I remember the family vacation. And are we there yet? Everybody knows that question. So from a design consideration standpoint, this comes up quite a bit. So we're now trying to add some new intelligence in there. And the first one is, of course, this interoperability. And that really speaks back to that open architecture. I want to make sure that all these different systems are going to communicate. So that's where you get into the interoperability piece. I don't want to put in something that's going to force me to use something else within that particular ecosystem. Back in the 80s, this used to be common with, say, instruments and some of the protocols that they used and some of the buses that were out there, is once you decided that was going to be your bus of choice, well, guess what? There's only one place you can go and get that. And vendor lock just became somewhat insurmountable. Talk about data model. Go ahead, John.
That's a key one too, David. You mentioned, building on a technology stack that allows you to bring in best in class, right? So that's true extensibility and being able to scale, right? Other solutions, when you are software locked, don't offer that. So that interoperability is a huge design consideration for I4.0.
Yeah, absolutely. Because you're going to be adding a lot more intelligence. There's a lot of intelligence that is not necessarily going to support what has been used in the past. So the more you can create that common denominator for everything, you're going to be better off from adding an intelligence standpoint. The next one is data models. And this is a really important one when you start on your transformation journey. So I mentioned earlier that all of these intelligence, they know what information they have, they know the structure of that particular information. And so you want to make sure that that gets sent out and published in a way that others can consume and identify what that is. So I will use the example of a compressor for a data model. So rather than sending up, say, 12 different tags that represent my inlet pressure, outlet pressure, or temperatures, or flows, or vibration, or a lot of the PLC tag information that you're going to be collecting on it, I want to send a data model of a compressor. And I want to have metadata that's associated with that. I'll sometimes use parameters as that also tells me about that information itself. So metadata becomes the, what am I, where am I located, who made me, what's my model number, what's my serial number. So that type of information can give some guidance as far as when that information is published, other systems know, oh yeah, that's our compressed air or a compressor in our instrument air system that is sitting out at the utilities at some particular site. That information comes through, and here's all the information about the compressor and the motor, and perhaps there's an air dryer that's associated with it. That comes in as a semantic model. Very critical to model assets in this process so that people are able to consume that information and understand what it is. And then, of course, once you're creating all of these data models, it's so important to maintain data governance. If people are allowed to do what they want with it, and maybe this particular site or area decides they want to model their compressors in a different way, makes it very difficult for other systems to consume that. So you have to have a mechanism that is going to enforce a lot of these. This is our standard for whatever it is that we're going to build. Same thing applies to a lot of your visualization objects. So if I want to present those on a screen, I know exactly what it is I'm looking at. That is an air compressor, and I know it because the underlying data model, as well as the overall image is there. And then, of course, security. We're going to spend a lot of time on it later on, but security is of paramount importance. We can all read the news and realize, wow, I have to be very, very concerned with what's going on. So from a design consideration, you also want to ensure that you're using things that are inherently secure. Is there just some security that's baked in to the product and the technology that I'm going to be using across that? So thoughts on this so far, John?
Yeah, no, I mean, that's a great point on the semantic data models, right? So as you build them data models, and you talked about the metadata, data about data, that's still data. But as you build the models, then you're starting to build in some intelligence, right? And that's where it becomes information for the consumers, right? Because you have the context with it. And I think that's a very important part in the design.
Yeah, and so from the functionality standpoint, not only are we going to model assets, we're going to model the function. So, I mentioned the compressor earlier in the air dryer. Well, that's kind of more of a device, but you're going to have that asset model. You also want to model your SCADA information. And what I mean by that is utilizing the ISA 95 Part 2, I'm going to have a model of my line and all the things that make up the intelligence that's on that line. That's going to be my individual cells, if that's what they're called, or machines. It's going to be the information about what am I manufacturing. So it's the process status. You want to know process health. How is my overall system actually working? That might be an OEE type metric. You also might want to know, well, what's my manufacturing work order or my sales order that I'm working against on this particular line? So that's more information that you want to bring in and introduce to that overall system model. Or if I have a downtime event on a particular cell or a particular machine that's on that line, I want to know, A, from a process health, yes, I have a downtime. And secondly, well, is somebody doing anything about it? And if there's a a maintenance work order that's being addressed or that's active on that particular piece of equipment, you're going to be able to see that information as well. So modeling assets, modeling the functions or the processes in the overall enterprise manufacturing side. So what I've shown you here is that information here is now sort of, if you think about how that information gets organized, think of it as the folder structure that you use, say, if you go into your file explorer on Windows, that I can drill into folders. And within those folders, there's going to be some pieces of information. Think of that as some tags. Or there's going to be other folders that either represent a logical part of the hierarchy, or it's going to represent an actual function in there. So I might have line OEE that's a data space or a namespace within that overall structure. So as a preview of coming attractions, our next webinar, we're actually going to start building out some of this functionality and demonstrating what that actually looks like. So as more intelligence is added to your overall production in your system, this is how you start small and grow it out to a full-blown enterprise unified namespace.
Yeah, so can you also capture like events in there, David?
So yeah, absolutely. It's when you start a production order. So it's knowing where you're going to it's the process segment is now going to get started. That event is captured. So within, say, an OEE system, I'm going to see that my system went from maybe I'm in idle where now I'm going to change my mode or my state. So where now I'm going to go into, say, a changeover mode where I'm getting ready to run that next production line. That event is tracked there and it's published to the unified namespace. So you're going to realize there's a state or a mode change that exists within your system. So when you see that, that can actually be used, that tag change, that event can actually be used to trigger some other workflow in the system. So that's how you get into the more of the event-based type of thing. So it's not just tag data that's coming in, there's events that get published and through the unified namespace.
So those are built into the data models and they enable the functionality of, say, like MES and tracking, like you mentioned, OEE. Yep.
Yeah, and we'll build out this use case in the next webinar series that we do. But think of it as the process of I have a downtime on my line, and so I'm going to capture the start of that rising edge of the PLC that says I'm down. You're now going to give some time for that operator to say, maybe it's just something like on a bottling line, something went wonky. See if the operator can fix it. If the operator cannot, then the operator is going to create a work order for the maintenance person to come out. So it will interact with the CMMS. You're now going to capture that information as well of, I just created a maintenance work order for somebody to come out and fix that. Then when the maintenance person comes to the line, you're actually going to find or determine and capture when does that maintenance person show up at the line to start fixing the problem. You now capture that event. And then, of course, finally, once the production line's back up and running. So we'll walk through that scenario and what it looks like as far as how the information is exchanged and what that data looks like as that process goes from beginning to end.
Very good.
So now let's get into a piece that is forefront for a lot of people, and that's the idea of security. So I talked earlier about the Purdue security model, and this came out of Purdue University, which largely was informed what became the ISA 95 standard. This architecture utilizes that same ISA 95 structure to where now I'm going to have, here's all my levels, 0, level 1, level 2. Then I'm going to now not only segment by zones, I'm going to create some different security layers through that. The challenge with doing this is that every time you integrate intelligence down here, you have to integrate it going from layer to layer. So if you want to get level 2 information up to level 3, you're going to have to do a point-to-point integration. Or if you're going from your level 3 into your DMZ, now you're going to have to integrate that information again. So it becomes a point-to-point. Or if I want to get it all the way up to my level 5 system in this diagram, once again, I have to do all of the integration there. Back in the 90s and 2000s, this was a great way to do it because you absolutely had to secure your systems. Mostly it's because it was driven by the idea that we have servers that instantiating the connection. So if this piece of intelligence up here wants information down here, I have to open up a port that allows that to happen. I'm going to be asking it some information from a higher level down to a lower level. And when that happens, that because of the firewall, you're actually opening a port in your network to do that. So to prevent systems from up here from actually doing the exact same type of thing, that's where you have to put in this architecture. And so while you definitely want to maintain some good layering in zones, and it's still there, or it's still a very valid approach to it, it's something to consider is that you want to ensure that the technology that you're bringing together makes it easier to where if I'm putting new intelligence here at a lower level of my process, that can be easily consumed by other systems without having to do all that point-to-point connectivity. And that's where we'll get into some of the inherent security that's within the unified namespace and some of the technologies that are used to build those.
Yeah, and we know IT does not like to open the inbound ports.
Mm-hmm. Yeah, opening ports is bad, especially as you go downstream. But as I mentioned, because that's when you do pull response, my server has to be able to get to the where the intelligence is, and that's what creates that security concern. So, and then I'll bring this up because I'm here to pick on the Purdue security model or say, oh, it's garbage. You don't want to do it. No, absolutely. You want to can still consider your cybersecurity and the implications of what it is that you're doing. But there's a better way to do it. And that's where we get into some of the technology that's utilized in building this unified namespace. So when you take a look at, utilizing an MQTT protocol, these are all client instantiated connections. So if you look at the equipment that's sitting down here on the factory floor, or really with anywhere within your enterprise, you're still going to have the concept of a device firewall. You want to make sure that all these ports are closed. You do not want to have any inbound connections. You don't want to let anything down your plant floor. But if you utilize a client instantiated connection, meaning that my client does the ask, you don't have to open any ports. This is very similar to you connecting to your bank. I don't have to, open up a port in my firewall to access my bank because it's an outbound only connection, and that's going to be available to me. Now, from a best practice, it is a good idea to only have that that port exposed and closed everything off. So the only thing that can actually go across that firewall is 443 from a secure web standpoint, or 8883, which is the secure version of the MQTT protocol.
And you mentioned the bank, so this is the same way you talk to like any like .gov or IRS.
Mm-hmm.
You're starting it, and you sometimes in the access control list, you also have multi-factor authentication too, right?
Mm-hmm. Yeah.
So that can be built in as well.
Yeah, absolutely.
But still, you're going outbound only, right?
Exactly. Now, when you get to your DMZ, this is where all that intelligence starts to connect together. Yep, you do open up those two ports. So from a firewall standpoint, it's, yes, you're still opening ports, but it's coming higher within your organization, or it's in a, this is that less secure area because it's got the open firewall, but you don't have to worry about anything that's connecting in here being able to go the other way because the technology is able to build that in. So, this is how we address that. It's the interoperability, data modeling, data governance. It's the security piece. Utilize technology that can enforce this. So now, if there's something that I think is a little weird on my my wire, I can easily close down all of these connections, and I can say, nope, something's going on. I can disconnect, and you don't have now you don't have that concern that I got to go close a port or somebody's able to access the information. But that's the advantage of building it. So going back to the whole UNS, minimum technical requirements, this is one that try to use security that is baked into the technology that's going to be used.
So you do list a interesting device there. That's a Groove Opto22 Groove controller, right?
Mm-hmm.
So that particular one does talk MQTT, but you could have a broker that pushes out, right, as well?
Yes.
Okay.
Yeah. So there is I think I put it in here. Yes.
Oh, sorry, I jumped ahead.
Yeah, you did, but that's okay. So, one way that you can account for, well, I still really want to have, so let's go back up here real fast. I still want to maintain something like this. Well, great. You can actually do that. So now you have that exact same type of infrastructure where I'm going to have a broker that's sitting at my, in my plant floor, all the lower levels. I'm now going to bring it into the same DMZ. I can bring it into, some of my business network. This is actually an architecture that was utilized for an oil and gas company. And then now I can finally land it in an Azure stack. The important thing to keep in mind here is that as these systems connect into this broker, this outbound connection makes its way all the way up to where any device that's connected down here can easily be consumed by the what's ever going on in the cloud. I don't have to make any point-to-point connectivity. That's fed all the way through. Again, there's no inbound ports to go down to these lower levels. And so the question we get asked a lot is, well, can I do any kind of control up here? And the answer is yes, because it is a persistent connection. You can get information back and forth. The real critical piece to remember is that the connection is only made from the lower levels up to the higher levels. Sparkplug now contains something known as command authorization. So even though you can do command here, you actually have, there's credentialing, so you have an access control list. You maintain an ACL to do that. You also have the ability to further enhance that to make sure that if all of a sudden you do get a bad actor that is able to connect into your broker itself, that you can minimize the amount of risk that you're exposing there. But That's how you can handle that. And if there's any concern over cybersecurity, you just immediately disconnect everything. These ports are closed automatically. It's just like logging off your bank, logging off your healthcare system, logging off your, paying your taxes or whatever those secure systems that you use. It's the exact same scenario.
So David, in looking at the layered brokers there from the different levels, and this is in a pub sub, publish and subscribe. Can you subscribe to branches so that if something new starts publishing, the upper levels will automatically start seeing that?
Yeah, that's the advantage of utilizing this technology, is that following that data model where now all of my data is going to publish into this semantic data model, and it's going to publish in a hierarchy. So as we were talking a little bit earlier about this folder structure, that if you're only interested in things that exist at the line layer across your entire enterprise, you can subscribe to anything that's publishing into that line namespace. So if new information is presented at the line, oh, there's new information. Let's take a look at what it is. When you can get the whole thing, you can get parts of it. You can get parts that are only, things that are only named line 1, or things that are only named, I'm an air compressor. So if all you're interested in is air compressors, that's all you subscribe to. Anything that identifies itself as an air compressor, you'll get. And you can utilize that. Go ahead.
So if I have an application, whether it's SCADA or above, maybe it's even OEE, and I'm dynamically just showing everything at that line level in the unified namespace, if I start adding cells in there or new assets, it just automatically will appear, right?
It automatically populates utilizing this technology approach, yes.
So I don't have to go in and redesign and build new screens?
Nope, sure don't. Nope, you can actually, if you have a new line that comes up, if you follow your design guidance, other systems will dynamically realize there's new intelligence. I know what this is, and I'm now going to start presenting that information dynamically. Yeah, absolutely. Great. All right, so I think that's all we have on that. And I think we're kind of coming to the end. So, we just throwing a whole lot of information at everybody. What types of questions are coming in, or is there still some, remaining? I'm not really tracking this. Keep in mind, our next session is going to actually show how these things get built, utilizing some actual real world examples. And we're going to build a model unified namespace utilizing some of the various components we saw here.
Sure. I believe the chat is open. If anybody has any questions and would like to put in a question, that'd be great. I don't see any yet, David. I have looked a few times.
Okay.
When we talk about Industry 4.0, I'll start us off with a question that I've heard a few times. In Industry 4.0, some people refer to the Holy Grail. Could you describe that a little bit?
Yeah, so the Holy Grail is where now all of our intelligence is connected. So everything and everyone is connected together, and all of these systems. So it's not just my SCADA and my MES is connected. It means that all of my people are also connected to that system. I am informed in real time what is actually happening in my manufacturing process. So that's everything and everyone is connected. You're now going to have you're going to know let me start all over. You're also going to have all of that information presented in a common data model. So any information that you are consuming and that you're being presented with, you also inherently know what that information is. So it's everything and everyone's connected. It's done in real time. You also have the ability to view everything in real time. So, that example that I gave earlier, say I want to know what line in my enterprise is currently running the best, meaning, and I could say best by what's the highest OEE that I have across my entire enterprise. You can find that information readily. So that's that, I can consume information in real time or get information in real time. If I'm doing it correctly, I can also get the future state of the business through this. So I'm going to start utilizing some tools that also can do some predictive capability of, at this current rate, we're going to be able to finish this particular production line, or at this current rate, we're not going to finish up this production line, or I'm making some bad quality. So maybe we go ahead and stop the production because we know we're not going to we're already making off spec product. So let's go ahead and stop now. Holy Grail also means that you are implementing some machine learning. So machine learning is just really its pattern recognition. That's really all machine learning is. So you can now start adding in some machine learning within your ecosystem, so you'll be able to apply that. You can also get into some artificial intelligence. So your AI systems, these are trying to simulate and emulate the human brain, but it's going to build out on those models, and it's going to start making some of these predictions of, based on your current machine learning model, this is where you're not going to make a good quality. And then finally, humans are going to then decide, yep, that's what we want to do. It's saying stop production. I agree. Let's stop production. Or, based on how you're running, you're supposed to, your asset is now going to fail within 4 weeks. But if you run it this way, you'll get 6 weeks out of it. That could be very important, because you might have a shutdown or some type of operational change in that 6-week time frame that says, we're going to be able to get to that particular outage, and then we can address that asset. So, that's really what the Holy Grail is. It's all about informing your business in real time and having everything data-driven. You become a data-driven company.
All right. Great, good explanation. There's a couple questions here, David. I'll just go through them real quick. Sam, thank you for the questions. On the first one, there are recordings. You'll get a follow-up email after this session, and I believe the links to the previous recordings are going to be in there. So hopefully you'll have an opportunity to review some of those. And David, Sam did have a question here. What kind of pain point an organization will face as they undergo their digital journey? Pain point tends to be the issue that prevents an organization from adopting the digitalization.
Sure. So generally speaking, it's actually the people become the biggest obstacle, and that's not the way we do it around here. So the biggest pain point is going to be convincing people that we don't want to do it the old way, we need to do it the new way. And there's several ways of overcoming those types of challenges. The first is from a Socratic of, well, let's start asking questions of, well, what if we don't change? Or, well, what if, and start asking these types of questions. And eventually people will come to the conclusion of, oh yeah, I think we need to do something. And the other one is, if you're going to become a data-driven company, there's some ways to go about doing it, understanding that's what you need to be, is a data company. If you don't do something along this line, and have that strategy, maybe your competitor will, and you might be the target of an acquisition somewhere down the road. But really, the pain point is that it's the culture shift. It's the way about doing things. It's getting everybody aligned. It's eliminating silos. That's typically going to be the pain point. The technology part, frankly, that's the easier part. It's just getting people to think differently and act differently.
Yeah, and I see Jim is itching to talk about how Matrix helps with that, with change management, right, Jim?
Actually not itching, but thank you, John. Yeah, and I was going to tell Sam, we have to, any of our clients that we help go through a digital transformation journey early, and I mean way early, we have to start talking about change management, change adoption, change acceleration, what that means, and making sure that all of the key stakeholders involved, and I'm talking shop floor to the top floor, are aligned on the commonalities of the why around digital transformation. I think the other part is these things don't have to be eaten in huge chunks. In fact, as you go through the previous 2 recordings, you'll hear concepts around proof of concept. And as you get ready to launch your unified namespace and developing a specific use case, you start there. And that's going to help a lot with the technical aspects Dave mentioned. But if you're not preparing your company for change, either internally, having a change management program and team, whoever you choose to help you needs to have a change management program in place that can help you all the way through it.
Sure, and I think that I'll just add, Jim, I think that's one of the keys up front is, finding the innovators and what we call like the change agents, right? We always talk about, project champions have been around for decades. We, always look at that when we're looking at business requirements and pain points. But yeah, for a digital journey that's going to take a while, it really helps to have change agents identified in various areas and different levels of the organization, right? And that's one of the key things to start with, right? David will say, let's help those who can be helped, right? Those who are really looking for change. We're not trying to force it down or sell it to someone. We want to help people. I think David said that in the very beginning. We're looking to help manufacturers. And as David noted, the data's there, the technologies are there. It's how do we take advantage of it? How do we structure that strategy and that path forward? And how do we start implementing change?
Absolutely.
Perfect.
I'm not seeing any more questions. I think we covered everything, all the questions I had, David. Jim, anything else to add?
I don't at this point. I can't wait to see part 4, which is part 2 of this one. What's the value, right? And it's coming down the pipe. And Sam, I will say that as we close out the 6th and final session, that one is actually on change management and how we focus on that. So we hope that you and the rest of the group stay engaged with the 4th through the 6th one. I think these will be very impactful to you as you start thinking about either your digital transformation journey or how you want to help others digitally transform.
Yep. Very good. All right. We'll give a few minutes back today, I guess. We can wrap up if that's all. I just want to thank everyone for their time. And David, thank you for going through everything with us. Mackenzie, thanks for setting everything up. Jim, anything else?
Just trying to keep my dogs from barking in the background. My apologies. Everybody have a great rest of the day, and until next time, late September, be on the lookout.
Yep. Stay tuned for part 2.
Absolutely.
Thank you, everybody.
All right. Thank you.